For real life graphs, sometimes the trend is going to be a little bumpy, and that's where we're going to have this new tool called a best fit line to help us calculate the slope or rate of change of one of those bumpier trends. Real graphs don't have perfect slopes, so we can draw a best fit line to get the slope. So I'm going to show you an example for our data here. We see it's a scatter plot that shows points for comparing the resting heart rate of a person based on the amount of weekly exercise they get. And it seems from the graph that the more exercise they get, the lower the resting heart rate is, which makes a lot of sense if we think about why that would be. So I'm going to show you how we could estimate the slope so that we could get an idea of how much that exercise affects heart rate. And the line of best fit is basically just an average sort of slope that goes through the middle of the data. And so there is a good line of best fit. It's following the trend of the points, and it goes through the middle of the data. And I also just want to take this opportunity to show you another way that you could draw a line through the middle, but that would not be a good line of best fit. So here's the red line. You see it goes pretty much through the middle of the data, but it's only going through the middle vertically. It's cutting the data in half. It's not following the trend. So this red line is a bad line of best fit because it's not following the general trend. So let's do an example here. We're going to draw a best fit line and then estimate the slope. So again, we need to make sure that our line goes through the middle of the points and just follows the trend. And it's best not to overthink it. Just do your best to get your ruler sort of smack in the middle of the line of all the points and is following the general direction of those points. And there's my line. And I'd say that's pretty good. Obviously, if it was just a little steeper or a little less steep, that would be okay. But you really need to make sure that it's following the trend. So there's a few different right ways to get a best fit line in there, but there's a lot of wrong ways. It has to follow the path of those points. And so if it doesn't do that, then you haven't drawn the best fit line correctly. So now our job is to estimate the slope. And so the way to do that is to find a couple of convenient points on the line. So I'm going to start by identifying this point, which lands right on my best fit line. And this one down here as well also seems to land right on my best fit line. And I'm going to use these 2 points to determine my rise and run. I don't want to pick a point that doesn't land on the grid line because that just doesn't help me any. So here's my run, and my rise would be from there up to there. So to start with, let's find my rise. So it's going from 40 kilograms up to 60 kilograms. So the rise is the difference between those, or 20 kilograms. And the run is going from 140 up to 154 centimeters. So I'm going to do 154, subtract 140, gets me 14 centimeters. So now I'm ready to estimate. So the estimate is coming from the fact that we have drawn a best fit line, which is sort of an estimate in itself. And depending on how well placed our points are on our grid, there's also a bit of estimating in there. So I'm going to calculate the slope, but all of this has relied on some level of estimating. So the slope is equal to the rise over the run, or 20 divided by 14, which is equal to 1.4, and I have to round here, 1.43 kilograms per centimeter. So what our slope is telling us is that for every centimeter taller or shorter you are, on average, your weight will change by roughly 1.4 kilograms. So again, there's sort of a range of answers that would be acceptable. Maybe 1.40 is an acceptable slope if you drew your line of best fit slightly differently, or you picked 2 points that were on your different line of best fit. So there's a range of answers. 1.40 would be reasonable. Something a little higher, like 1.5, might be totally reasonable. The really important part is to show all your work and all your steps in questions like this. So we started with just using some scatter plots where we had a bunch of points, just because it's a little easier to see how that line of best fit would work. But we can also do a line of best fit for a bumpy line graph, and these are really closer to the examples we've been seeing in the course so far. So again, we can see that this is following a general trend upwards, but in order to calculate a slope, it helps to draw a line that sort of matches the average upwards trend. And so I'm going to try to do that here. There we go. And so there's my line of best fit that's trying to match roughly the average trend. And you can see because the line dips a little lower and then dips a little higher, what I'm really trying to do is capture that average. It's a straight line through the general trend.